One of the best kept secrets from beginners is the topic of design patterns. Design patterns are a way to organize your code so that it's more maintainable, so that when you want to make changes to your existing code, it's unlikely to introduce bugs in other parts of the application. And even the first time you implement it, if the code is well organized, it's going to be easier and faster to implement with less risk of coding some incorrect functionality, less risk of coding a bug. So let's look at an example of how design patterns could be used to clean up some code. So let's say you have a name and address form. You've got a class called person, and it's got these name and address fields here. But let's say it has a couple other fields with some more complex validation rules. So let's say it also has salary. So this could be used for like an internal app that has a list of your employees or something like that. Or maybe, you would probably want that field to only be viewable by managers. And then let's say you have another field like medical history. Maybe it's an app that's used by a medical clinic or something, and only medical employees like doctors and nurses are allowed to see and edit that field. There could be other people like secretaries or managers, and they don't get to see the protected medical information. So now let's say you want to write a function like update person, where this function is going to run when the user clicks save on the person form, and it's going to update an existing person and edit some of the fields. So what is this function going to need to do? Well, it's going to need to do many different things. First of all, it's going to need to check if the user is authorized. So is it a manager who's trying to update the salary field, or is it a malicious user who's trying to do that with an account of just a regular user? Same thing for the medical field, right? So we're going to need to load the user's roles from the database. That's going to be many lines of code. This is just pseudocode, so this query is not complete. We're not actually doing anything once we've read the data, but in a real app, it's going to be even more code than this. Then we're going to need to check to see which fields did they attempt to update. So in most apps that I've seen, when you click save, it sends the entire form to the server. It doesn't just send the fields that change. So if the app is coded that way, you're going to need to load the original record from the database and then compare it to the person record that you've been passed in as a parameter. So that's, again, many lines of code. This query could have many joins with complex relationships and that sort of thing. Inside of this reader block, you could have many different fields here, so that could be a lot more code in a real app. Now at this point, you're ready to actually do the validation and check to see, has the salary field changed and is the user a manager? Has the medical history changed and is the user medical? And in addition to that, so each of those, it's not going to just be one line of code, it's going to be many lines of code for each of those comments. And then in addition to that, you've got all your regular validations. So you're going to have a bunch of required fields like name and address line 1. Address line 2 will probably be optional, and then you've got some of the fields are going to have more complex validation rules, like with zip code or postal code. It's probably not only is it required, but it's probably going to have to be a certain length and format as well. So if you've reached this far without encountering any validation errors or permissions errors, then you're ready to save the record. That's, again, many lines of code. And if there was a validation error or a permissions error, you're going to have some logic for how to display that to the user and then return the response. So this function is quite complicated. It's doing many different things. It has many levels of nesting. And this is the coding style that you want to avoid. This is what you see in most business apps, but you really want to avoid writing your code this way. So how should you do it instead? Well, each of these different steps could be a different function. Like every time you see that I've put a line break here, between the line breaks, that could be a different function. So loading the user's roles could be one function, loading the original record could be one function, doing the salary logic, one function, doing the medical logic, one function, doing the validation for the regular fields could be one function, and maybe even that could be broken up into different functions depending on how complicated those validation rules are. Saving the record should not only be a different function, but it should be in a different class, right? That should be in a repository class in your data layer. Same thing with these database calls. If you make those in a repository class in your data layer, then you could do unit testing and dependency injection. So that's another thing that should be broken apart. And then even the error handling and deciding like what error message you're going to show to the user. There could be some logic there that could be handled in a different function, and even creating the response object that you're going to return to the user. There may be some logic there depending on whether it's a success or an error message that you're showing. So if you were to break each of those steps into a different function, each of those functions would be pretty easy to write because they're so simple. And then this update person function, it would just be a series of function calls, right? 1, 2, 3, 4, 5, 6, 7, 8. So just 8 function calls in a row. Maybe some variables to store the returned values and pass them into the next function. But other than that, just a bunch of function calls. And that's where the name Facade comes in, because when you see those 8 different function calls and no real logic or database calls and stuff like that, not until you drill into those helper functions, that creates a facade that this function is actually something simple, when really inside of those helper functions you do have some complicated stuff going on with many levels of nesting. So that's your first design pattern, the facade pattern. Whenever you find yourself writing a long and complicated function, it's always worth it to break it up into many different small functions. The rule of thumb that I've heard is that you should be able to fit one function on the screen without scrolling. And when you do that, it's much easier to reason about the function. With a long function like this, and this isn't even complete, right? This is pseudocode where the queries aren't complete and stuff like that, and this is already something that I have to scroll through to see the whole thing. So that makes it much more difficult to reason about the function. If you're looking at a screen full of code like this, you're not sure, what variables were declared up here and how could that affect the functionality of this code right here. When you can see the whole function without scrolling, it's much easier to understand it. So that's it for today. I hope you enjoyed this introduction to the facade pattern. Remember to like, subscribe, comment, and share. See you later.